What if everything you see, this world, this room, even your body, isn't as solid or real as it seems? What if the entire universe is actually a hologram? No, not like the shimmering images from sci-fi films, but something far deeper and stranger. The holographic principle is a cutting-edge idea in theoretical physics. It suggests that everything in our universe, from galaxies to atoms, may be a projection from a more fundamental two-dimensional reality. In this episode of Infinity Beyond, we peel back the fabric of space to explore the question: is our 3D world just an illusion? What is a hologram? A hologram is a 2D surface that encodes information to appear 3D when viewed. Think of the image on a credit card or security sticker. It's flat, but when light hits it, you perceive depth. Now imagine that our entire universe is like that. What appears 3D, space, objects, time, might be information encoded on a distant, flat boundary of the cosmos. It's a radical idea, but it's grounded in real physics. The black hole connection. The roots of the holographic principle begin with black holes. In the 1970s, physicist Jacob Bekenstein discovered something strange. The amount of information, or entropy, inside a black hole doesn't scale with its volume, but with its surface area. This shocked physicists. Normally, you'd expect more volume to mean more information. Later, Stephen Hawking showed that black holes radiate energy, and this led to a paradox. Information seemed to be lost when a black hole evaporates, violating the rules of quantum mechanics. How could that be? To solve this, physicists like Gerard T. Hooft and Leonard Susskind proposed a bold idea. The information isn't inside the black hole, it's on the surface, just like a hologram. The holographic principle. This principle says that all the information contained in a volume of space can be represented as data on the boundary of that space. It's like compressing a 3D object into a 2D description. In 1997, physicist Juan Maldacena gave the idea mathematical strength through what's now called the ADS-CFT correspondence, showing that a gravity-based universe in a 3D space can be fully described by a quantum field theory without gravity in a 2D space. This was a breakthrough. It showed that reality might be emergent, built from a deeper, lower-dimensional reality we don't directly perceive. So, are we in a hologram? Not in the sci-fi sense of flickering images, but if the holographic principle holds across all space, not just black holes, then our entire universe might be encoded on a cosmic boundary we can't see. Our 3D experience of reality would then be like a projection, not fake, but not the most fundamental layer either. Some physicists compare it to a video game rendered in 3D, while the code and data exist in 2D. We're real, but the source of our reality may be elsewhere. Implications for physics. This idea could solve some of the biggest puzzles in science. Quantum gravity, unifying general relativity with quantum mechanics. Black hole information paradox, preserving information on surfaces. Dark energy and space-time. Geometry, rethinking what space actually is. If space, time, and gravity are emergent, not fundamental, then the real bedrock of reality might be information itself. In this model, bits of data, not particles, are the true atoms of the cosmos. Does this affect you? Philosophically, yes. If we live in a holographic universe, it challenges how we understand. Identity. Are we the projection or the projector? Perception. Is what we see a rendering of deeper truths? Consciousness. Could it too be emergent from quantum information? It also connects with ancient spiritual traditions. Hinduism's concept of Maya, illusion. Plato's allegory of the cave Buddhist teachings on impermanence and emptiness. Maybe science and mysticism have been touching the same mystery from different sides. Could we test it? In principle, yes. Some researchers are trying to detect quantum noise, the pixelation of space, as a sign of holographic structure. Experiments like the holometer at Fermilab aim to measure whether space itself has a grainy texture, as predicted by some holographic models. So far, results are inconclusive, but the effort is ongoing, because if proven, it would revolutionize everything we know about physics. A universe of information. What if the universe is a vast quantum computer, each particle a bit, each interaction a computation? This would mean that reality is information, and matter, energy, and space are just emergent phenomena. We wouldn't be any less real, but we'd be infinitely more mysterious. Final thought. The holographic principle doesn't say the universe is fake. It says it might be stranger than we thought. A deeper layer of reality where space and time dissolve into information patterns beyond imagination. Here on Infinity Beyond, we explore not just the stars, but the code behind the cosmos. Because to understand where we are, we must first understand what we are.